Bismillah, alhamdulillah, salatu salam ala rasulullah. Welcome everybody to this little demonstration about my recent tool that I just created using Python, as always. So this particular software will actually transfers data or will do data exfiltration throughout advanced techniques like transferring, in this scenario, transferring any kind of data like shellcode or confidential data throughout a legitimate protocol called ARP, Address Resolution Protocol. So this is the victim machine, which ends with 102. This is the attacker's machine, which is Kali Linux 222. And let's set up the multi-handler. Set up here Linux payloads and a port of 4545. So what I'm going to do is to hit exploit. So I'm listening on port 4545. So if we do next np grep on 4545, you found out that Ruby, which is Metasploit, is listening on this port. So what's behind this? Why am I doing this? So let me first run Wireshark, and you're gonna figure it out momentarily. So I'm gonna start sniffing on WLAN 0, which is my interface, and I'm gonna just do opcode here 001. Okay, arp.opcode. So I'm gonna listen on ARP request, which stands for 0x0001. Okay, ARP request, and you're gonna see in the background that Wireshark is displaying there. So let me show you my software. This is the ARP payload fetcher. So what it does, it makes use of raw sockets here and listens on any kind of packets, filters out ARP requests that are going to this particular address, adding to a payload, passing to a shell exec function. So what this is about. So as you will see here, I have here my data. Here I have the program that will be installed on the attacker's machine. So I am an attacker here, and I'm going to start this program, which will actually take a shellcode. This is a shellcode. So you can generate it using MSF Venom. So as follows. Okay, so 31 dB and ends with 80. Okay, so 31 dB and ends with 80. And these are knob slats, just for padding. I'm gonna explain. So my packet or my software here will simply create an Ethernet header, okay, as the broadcast address. I'm gonna send the packet to the broadcast address, and the source MAC address is mine, okay. The ether type is 0806. This tells the kernel that the next header is an ARP header, and indeed I am developing here an ARP header, okay. So this is the ARP header. So we've got here the Ethernet type, which stands for Ethernet. Prototype is IP. Hardware size is 6, which is the size of the MAC address. The protocol size is 4, which is the size of IP address. The opcode is 1 in case you're gonna send an ARP request, 2 for sending an ARP reply. Okay. The source MAC is the broadcast. Source IP is any kind of IP, because we are not interested in answers. We are going to transfer our payload as a MAC address. So the shellcode has been split out into a couple of MAC addresses, as you can see here. And finally, we are going to add padding, okay, as null bytes or knob slats, no operations in assembly language. Then I'm going to pack the packet as the ARP header, so 2 byte, 2 byte, byte byte, 2 byte, 6 S for S6, S for S stands for destination MAC, source MAC, source IP, destination MAC, destination IP, and I'm gonna pass my options there. So once that's done, I'm gonna loop through the shellcode, each MAC address, pass it to the class object, and generate a packet and sends it over the network. Okay, so let's execute it. So once these ARP packets are sent, my software in the victim's machine will try to sniff packets using raw sockets and filters them out. Okay, so before explaining this code, let me run it. ARP payload. So now my software is listening. Let's clear out Wireshark. Let's hit transfers. So as you can see here, I am receiving MAC addresses, which appears to be MAC addresses. And as you can see here, this is a valid MAC address. But indeed, this is our shellcode passing as MAC addresses. What do you think? Okay, so we've got 12 packets here. And after that, we've received a shell. Okay, so who am I? LS, and there you go. So this is magic. Okay, I know this is magic. So let me explain this particular fetcher. So I'm gonna import the thread from the threading module. I'm gonna import some socket functions like the PF packet that will be used here to listen on the data link layer, and sock_raw, which stands for raw sockets. So this tells the kernel that I am in any kind of packet that will be passed to you, just accept it as it is. Or if I'm going to receive any kind of packet, just let that packet comes to me. Okay, and the HTONs, this translates this particular 2 bytes into an IP, into a network byte order. And simply put, this particular code can be acquired from this particular user live include or user include Linux ether or if ether, and I'm gonna grab on this code. As you can see here, this is the defined value of an address resolution protocol. So I'm telling it here that I am interested in ARP packet, and I'm gonna set some flags. So this is the class, a class using Python, and this is a threaded class, and this is the constructor, and I'm going to inherit anything from the threading module. Okay, and which means this class's constructor will inherit any kind of methods from the threading class. And I'm gonna create a socket type of which listens on the data link layer, raw packets, and I'm interested in ARP packets. I'm gonna set some flags like read, write, execute, just for memory protection, as will be explained later on here. And finally, I'm gonna just listens on or receives data from the socket, and this kind of the maximum buffer size. Okay, next we have a function here called shellexec. Before explaining this particular function, let me explain the run function. The run function grabs a global variable called payload, which is pointing to a null string, and I'm gonna just get the packet from the ARP header. As you can see here, ARP data. Okay, ARP data, and this is the ARP data. So the ARP header starts from byte 14 to byte 42, and we know that the ARP packet size or header size is 28 plus 14 is equal to 42. So 14 is the Ethernet header the Ethernet header size. Okay, so the source MAC address is 6, destination MAC address is 6, and the ether type is 2. So 6 plus 6 is 12. 12 plus 2 is 14. So this is the packing format. So 2 by 2 bytes. This is how I'm going to parse this packet. So once that's done, I know that the request type is located on byte number 5, which is 0, 1, 2, 3, 4, 4, and 4 is the 5th field. So this is I'm interested in ARP request, and as I am sending this packet to target MAC address has a target IP address has 255.255.255, I'm going to filter that out. Okay, so once this condition is happened, I'm going to hexlify the MAC address, the destination MAC address, which contains our first portion of the shellcode. I'm calling it as chunk, and I'm gonna add it to the payload. Once the payload is there, I'm going to check if this chunk it ends with NOP/SLED. As it is not ending with NOP/SLED, I am going to repeat the scenario, start receiving until this condition happens, and I'm going to create a memory with shell variable that is pointing to the self.shellExec. So what this does, simply put, the shellcode will be received as follows: this value concatenated with this, etc. So I need to make the shellcode as a real shellcode, as this. I need to add the \x at the first of each byte. So I'm going to use the join here to join a integer, and I'm going to convert it to a using chr2. This takes the ASCII value. Okay, and I'm gonna take the payload from I to I+2 for I in X range 0 to the length of the payload up to 2. So let me give you an example of this, just to make things clear. Okay, let's take this one. Okay. Python. Okay, our payload is going to be this one. Is going to be this one, and let's just go ahead and do it. So as you can see here, it converts it into an hexadecimal and adds a \x to it. Okay, so once that's done, this value is passed as a buffer, as a shellcode to this function. Okay, as you can see it here, and I'm going to load the libc, which will create the allows us to allocate memory and actually do some memory protection. So I'm gonna allocate a buffer, get the size of it, allocate a memory, and then makes it readable, writable, and executable, or using the memory protect method, and return the address of the shellcode of the buffer. Okay, return the address of the buffer, as you can see it here. Once the shellcode is set into this particular IP, into this particular address, simply put, I am going to return it into this variable and call the cast function that will accept any kind of data, just accept any kind of data, and it will try to execute that particular memory address and start it as a new thread. Okay, and here I'm going to create an object, set it as a daemon in case you are interested in interrupting it, and start the thread. Hopefully you like this software. See you next time.